Hello friends. So this problem is about calculation of force on a pendulum bob which makes a vertical circular motion. So the problem says a simple pendulum of a string of length L and bob of mass M is suspended from a point O and bob is taken aside so that the string becomes horizontal from this position. And then it is released. We have to find the total force acting on the bob when a string makes an angle theta with the vertical during its fall. So here I have a pendulum bob and this is attached to a string. Length of a string is given L and the mass of this bob is given, this is M. Once this is released, this will basically make this circle. And certain point of time this ball is here. And this point, this makes an angle theta with the vertical. And the point of suspension is given O, and this is basically vertical line. So this is the mean position. So what are the things that is given? So we have been given mass of this bob, length of the string, and this has been released from the rest and from the horizontal, this is also given, and theta is also given. So we have to find for this theta or at this theta, what is the total force that is acting on this bob. Now how will you solve this problem? So what you have to find total force. So you have to find force. And how you can find force? So if you remember, if you have multiple forces, so let me write something like this. You have to find force. Now if you remember, you can use a square root formula, F1 square plus F2 square plus 2F1 F2 cos theta to find the resultant force. Now in this case, what is F1 and what is F2? That we have to figure it out. So let us first draw the free body diagram and then it will be more clear. So at this point, one force that is acting is mg, and there is a force that will act in this direction, and this force will be tension, and this angle is theta. So basically if I take the resultant of this force T and another force mg, I will get the total force. So this means in one case F1 may be T and F2 is mg. So mg is known to me. So now my problem is basically calculation of tension. So how will you calculate? So calculation of tension. Now this is moving in a circle. So we can use two things. So first we will use equation of motion. So we will use equation, that is force in the radial direction is equals to mass into acceleration in the radial direction. And then we can also use energy conservation. So with this all hint, let us pause this video and solve this problem. So let us solve this problem. So what you will have in this case, so first equation in the radial direction, so force in the radial direction is T, and this force will have a one component is mg cos theta. So we can write T minus mg cos theta is equals to mv square by L. So let us say at this point velocity is v. So this is one equation, and the second equation we can write using energy conservation. So what is the loss in potential energy? So this is the final position. So this position, so this is the loss in potential energy. So this length is L, so this length will be L cos theta. So loss in potential energy is mgh, in this case mgl cos theta, is equals to gain in kinetic energy, that is half mv square. So from here I can write V square is equals to 2ZL cos theta. So this is equation 2. So from equation 2, now we can plug this in equation 1. So equation 1, we can rewrite this is T minus mg cos theta is equals to mv square by L, and v square by L is nothing but 2z cos theta. So from here I can say T is equals to 3mg cos theta. So now I know tension and another force is mg that is acting in this direction. So mg is acting in this direction and tension is acting in this direction. So now we can basically take the resultant. And this angle is how much? So this angle will be pi minus theta. So the angle between these two is pi minus theta. So let us find resultant force. F will be, this is mg whole square, one force. Another force is 3mg cos theta. So this square plus 2f1 f2 mg times 3mg cos theta into, so 2f1 f2 cos theta, and cos theta in this case is pi minus theta. Theta is pi minus theta. So this will become m square g square, and this is 9m square g square cos square theta, and this is 6m square g square, and this is cos square theta, but cos pi minus theta is minus cos theta. So this is simply m square g square plus 3m square g square cos square theta. Or other way we can say this resultant force in this case is equals to, if I take mg common, so this is 1 plus 3 cos square theta. So this is the resultant force that Bob will see at any given theta. Basically there is an alternative method also to solve the same problem. So in this alternative method, what you have to find? You have to find basically force, and you can find force that is mass into acceleration. So resultant force will be mass into resultant acceleration. But this acceleration will be composed of radial acceleration and tangential acceleration. So how do you calculate resultant? Basically a square root of radial acceleration and tangential acceleration. So once you know the resultant acceleration, then you can calculate simply force is equals to mass into acceleration. In this case, if you see, there are two accelerations. One is acceleration in this direction, that is radial, and this is equals to v square by L. And acceleration in this direction is simply force by mass. Force in this direction will be mg sin theta divided by mass. So this means in this direction you have acceleration of g sin theta. So this is tangential acceleration. Now in this problem we have already calculated v, so we can calculate radial acceleration, that is v square by L. So v square was 2zl cos theta. So L cancels out, so this will be simply 2g cos theta. So this is the radial acceleration, and tangential acceleration is g sin theta. So the resultant force will be mass times acceleration. Resultant acceleration will be a square of tangential acceleration plus a square of radial acceleration. So this will be mass times g square sin square theta plus 4g square cos square theta. And then if you take z outside, and this sin square theta plus cos square theta becomes 1, so this becomes 3 cos square theta. So this is the resultant force. Now both method gives you the same answer, Now the question for you, which method you prefer and why? So let us discuss this in the comment box and I will see you in the next video. I hope you enjoyed this video. If you enjoy, please share with your friends and subscribe to the channel. Thank you.